Hi everyone, this is a tutorial on utilizing randomness in TidalCycles. I think randomness is key both in TidalCycles and in live coding in general because it allows you to give up some creative agency to your instrument, in this case, a computer, which can result in some really surprising and exciting sounds. So really quickly, I just want to run through what I'm going to talk about. First, we're going to look at the rand and irand variables. Then I'm going to look at the choose and wchoose functions, then the sometimesBy function, and then I'm just going to run through some additional functions and techniques that I use to wield randomness in TidalCycles. Apologies for the flickering screen. I do not know how to fix that right now. All right, let's get into it. So here I have a function that sequentially runs through every sample in the default amen break folder for TidalCycles. I think it's called amen cutup when you first download it, but I just renamed the folder. It's the same sounds. But anyways, let's hear what that sounds like. So that sounds fine, but unfortunately, after a while, it just loops back and we get the same pattern of samples over and over again. So what if we wanted to shake things up and randomize which samples were being played? Well, we can replace our run function with the irand function. And what irand does is it pseudo-randomly generates a number between 0 and n minus 1. So in this case, between 0 and 31. And so when we play this now, we should get something a little different. Right, so that's irand for generating variables like that. We can also generate decimal values using rand. So let's say I wanted to randomize the gain for this pattern. I could do gain and then use rand, which will generate a value between 0 and 1 inclusive. So now when we play this, so that's including a lot of very low values, which is why it sounds so quiet. But if we want, we can change it so that and add 0.5 so that we're working between values now between 0.5 and 1.5. So this might sound a little louder. So one thing to keep in mind with rand and irand is that they are pseudo-random, which means, to the untrained ear, the numbers that they generate sound totally random. But if you were to reset the cycle count back to 0 and use these functions again, they would produce the same values every single time. It's still a deterministic pattern. So to see that in action, let's do something a little more simple here. I'm going to have it be irand2 so that it's choosing just between the first two samples in the amen folder. And then I'm going to do irand2 for the gain. And so that means it's going to be choosing between 0 and 1 for the gain. And what this is meant to show is that the values that both of these irand functions are generating are the exact same. And so when I run this, you should hear that the only one sample ever gets played because it chooses the same value for the sample and the gain. So let's listen to that. And if I cut out the gain, then we get this. And we suddenly hear the second sample. So it's important to keep in mind that you can't just keep using the same rand or iRand values all over your code in case you really want some like dynamic randomness. You're going to have to switch it up a bit. And one way to do that is to add a slow function to one of these iRands. So if I add slow, if I slow it down by 2, what happens is it kind of spreads out the determinist pattern that we were working with before and will suddenly be off the beat of this other iRand function. And actually, let's just make it 2.2 because I don't know if it's going to be like perfectly half or whatever. So let's try that now. So now we have both samples being played with a random gain. So yeah, it's not too much work to type in some extra slow functions, and it could really make the difference when implementing randomness into your code. So now we have a way of randomly generating variables for our patterns. But what if we want to be a little more specific with what values are being generated? Well, we can first use the choose function, which allows you to randomly select from a specific subset of values. Let's say in this case, I only want to use about 5 different samples from the amen folder and just those 5 samples. I can use the choose function, add in the corresponding numbers to the samples in the folder, and now when I run this, only these 5 samples will be played in a random order. So we're getting closer to purposefully wielding this randomness, but we can get even closer. In this case, what if I wanted to make the possibility of there being a kick drum higher than the possibility of another sample playing? Well, there's 2 ways I'm going to walk through right now. The first is you can just pack a bunch of kick drums into the choose function, which essentially ups the chance of one of them being played. So when we play it now, you can clearly hear that there are more kick drums than any other sample being played. The other way of doing this is using the wchoose function. And this is not actually defined in TidalCycles inherently. You have to write it in. So I'm going to just paste it in because it's a lot. And I'm not going to claim that I know what's going on here. I'm not a Haskell programmer, and so I can't adequately explain what's going on. But if you just write this out once, put it in your boot file for Atom, you'll never have to write it again. And there's a tutorial that Kindo made about Atom boot configurations, which I'll put in the description of this video. But what this function does is it allows you to, it's kind of a more streamlined way of weighting the possibilities for the choose function. So let me run that. And here, if I want just a kick and a snare, but I want more of a possibility of a kick, what I would do is first in brackets and then in parentheses, define the weight, let's say 40 for this, and then the sample number, in this case 0 for kick drum. Then you do the same thing with your second, third, and so forth samples. Let's say a weight of 5 for the snare, and the snare is the third sample in the folder. So now when I play this, you should hear a lot more kick drums and snares. Right, so choose and wchoose, much like rand and irand, you can apply them to selecting samples, changing the values of effects, of other functions. You can randomize the weight within wchoose. There's a lot of possibilities using just these two functions. So far, we've been dealing with generating variables for effects and functions. If we want to control randomly whether or not an effect or function happens at all, we can wrap those things in sometimesBy functions. So here I have a stutter function, which is a kind of echo. And so when I play this, it's going to sound a little echoey. So that could get overwhelming. So what if we wanted to make that only happen some of the time? We can wrap this stut in a sometimesBy function, and sometimes takes a single value which determines how frequently the event occurs. So let's say we want it to happen half of the time. It's going to sound like this. And if we only wanted it to happen 1/10 of the time, and if we wanted it to happen 100% of the time. So this could be very powerful for mashing effects together without it becoming overwhelming. If you stack a lot of sometimesBys together, you can get some really interesting cross sections of effects. There's also some shorthand functions for sometimesBy, rather specific values of sometimesBy. I'm going to paste the aliases in here. So we could write sometimes instead of sometimesBy 0.5 and get the same effect. Let's get this out of the way. In addition to that, we have often, rarely, almost never, and almost always. And I'll put those in the description to this video as well. There's also, in addition to sometimesBy, which applies the function randomly throughout, we can do somecyclesBy, which will apply to entire cycles. So if we do that for half the time, we'll get this. So that's a little more of a controlled way of using that kind of function. Okay, so now I'm going to just rapid fire run through some additional functions and techniques that I use to implement randomness into my code. The first of which is spread choose. It's like choose, except instead of selecting different values, you're selecting from entire functions and effects. So I've added a bunch of those into here, and what you'll hear is that one of those effects or functions plays at a time in a random order. Up next is scramble. It takes a single integer value, n, which will divide a pattern into n equal parts and then play those parts in a random order. So I've got a pattern here with 4 kind of smaller patterns within it. When I run the code, scramble will play each of those in a random order. So what you'll have heard there is that there is some times where a certain subsection would repeat multiple times in a row. If you want to avoid that, you can use shuffle, which is nearly identical to scramble, except instead of playing a completely random arrangement of the subpatterns, it produces a permutation of them. So one pattern will not play until all the other ones have played as well. So you'll hear something just slightly different this time around. So with scramble and shuffle, if I was to make the n value higher, it'll start chopping these smaller sections into even smaller sections, and that's when you can start getting some interesting kind of jittery patterns. So actually let's up this up to 16 and hear what that sounds like. Up next is randcat. If you're familiar with slowcat, it's very similar, except it just plays the patterns in a random order. You separate the patterns by commas. You can add effects or additional functions within each subpattern, and it will just play them in order. It'll play them in a random order. Next one is kind of tricky. It's the stripe function. And this was developed basically over the course of a brief chat in the Tidal Lurk forum because of a certain effect someone was trying to achieve with their code. It's kind of hard to describe. I think the best way I can describe it is that it takes an integer value n and then it plays a pattern n times within a single cycle and randomizes the speed of those n patterns. That's kind of tricky to put into words, so I'll play this and see if that makes it any better. So I guess within that context, stripe makes it so that each of those speed changes, 2 of them add up to the length of a single cycle. And stripe is useful when you want to time something like a scale function, something that relies on a cycle length, with something more randomized. So if I was to use like a random fast function here, my high pass filter would go out of sync with the pattern and would not align with the various speed changes. But with stripe, you can hear that is no longer a problem. So what you should have heard there is that each time the speed changed, or it was a new stripe, so to speak, the high pass filter reset to the beginning of the scale. So that is really helpful if you're trying to get that kind of algorithmic club sound that some producers use, or kind of that's their style. I'm thinking of like Kingdom, Second Woman, Mark Fell, people like that. This function is really helpful for achieving sounds like that. And slow stripe is an additional function, which basically, if that was too fast, it just also slows the pattern down by the same value. So this just slows it down by 2. Up next is degrade by and the question mark operator. So both of these randomly remove events in a pattern. In this first function, let's set that to 0, and this is what it sounds like. Just an assault of kick drums. So if we want to change that, we can increase the value of our degrade by function. So let's say I set that to 0.6. Now 40% of the kick drums will be removed from the pattern. The question mark operator is a way of using degrade by within a pattern itself, except it's the equivalent of degrade by 0.5. So here, let's just play one of these on its own first. You'll hear that instead of 4 kick drums, it is randomly removing certain kick drums. Now, as with most randomizing functions, you have to be careful with stacking question mark operators because it is pseudo-random, and using multiple question mark operators with the exact same amount of notes or the exact same pattern will produce the exact same result, as is the case here. So that's just something to be careful about if you end up utilizing question marks a lot in your code. These next two aren't unique randomizing functions, but they're techniques I use to kind of rein in the randomness to my liking. The first is the discretize function. Discretize will divide a pattern into n parts and then apply a different value to each of those parts. So in this function, it divides this kick drum pattern into 2 parts, and then for each of those parts, it will only use one value from this choose function. Another way of thinking about it is that it holds the variable, the choose function, in place for a given amount of time. So let's hear what that sounds like. So if you find your random functions sounding a little all over the place and you want to rein them in a bit, discretize is really helpful for that and can give you a sense of structure if that's what you're looking for in a composition. Finally, this is something that Yaksu brought to my attention in the Tidal Lurk chat, shoutouts. You can automate the value of sometimesBy so that over time, the effect it applies to becomes more and more frequent, but still being applied randomly. And you can do that through this do block. Now, Kingdom has an entire video on do blocks, which I will also put in the description of this video. But what it does here is it essentially lets us convert this slow scale function into the type of variable we need for sometimesBy. And so what you'll hear is that over time, this stut function will become more and more frequent and then become less frequent. So that's a really good way of giving a composition some structure, but doing so in a way that maintains the sort of random integrity, if that's something that you so desire. So those are just some techniques and functions that I use. This is by no means an exhaustive list. I encourage you to mess around with random functions, because the more you expose your code to them, the more unexpected things your computer will do and lead you to some new discoveries. Randomness can be used in everything from sort of organic ambient sounds to just mixing up a pattern for a techno track. And the barrier between those two uses is almost non-existent. One time I made like a really random noisy sound using randomness, and then I just added like a striate function and a chop function, and in a few seconds it had become like a looping noisy synth that I put with a kick drum, and it sounded like some really interesting techno. So the world's really your oyster with randomness and tidal cycles, and letting your computer guide you to new sounds you didn't even know was possible is something I would highly recommend spending time with. All right, well, thank you so much for watching this video. If you have any randomizing techniques or want to correct me on anything, let me know in the comments. And hopefully I will be doing more videos like these in the future. All right, peace.